Today on Centurion Math, we'll be isolating a variable with multiple steps. The single-step equations that we've done before are ones where we only have one operation to get rid of. In this case, we only have a plus 3 that is beside the x. We want to eliminate this plus 3, and how we do that, like we did before, was we performed the opposite operation. So since we have a plus 3, what we're going to do is we're going to subtract 3 from both sides of the equal sign. So we have a minus 3 plus 3. So this plus 3 minus 3 works out to be 0. And so we're left with x plus 7, or sorry, x plus 0, and that equals the 7 minus 3, which is 4, or we just simplify that to just be x is equal to 4. Now the question comes in, is what do we do if we have a couple of different operations on one side? How do we handle that one? We still have our rules that we had before. We need to get x all by itself. And how we do that is we perform the opposite operation. But which operation do we perform first? In the case that we have up here, there's a multiplication and we have a subtraction. Well, one of the ideas that we have is that we have an order of elimination. This is similar to when we are simplifying an expression. We have an order of operations for simplifying, which we commonly refer to BEDMAS. Now the order of elimination is actually the opposite of BEDMAS. It's what I commonly refer to as SAM-DEB. You see, in this case, we want to get rid of the subtraction addition first, then the multiplying and division, next the exponents, and finally whatever's inside of the brackets. So with our original equation that we had before, we have 3x minus 5 is equal to 7. So in this case, when we take a look at SAM-DEB and the order that we need to eliminate between the multiplication and the subtraction, the s comes before the m. So we want to eliminate the subtract 5, and how we do that is again with the opposite operation. So 3x minus 5, to eliminate the minus 5, we add 5, and we follow our rules that whatever we do to one side, we need to do to the other side as well. So we have a plus 5 there as well. So the plus 5 and the minus 5 here together, they eliminate themselves down to 0, and we're left with 3x is equal to, we have 7 plus 5, which is 12. And so we need to then eliminate this multiplication. So we divide by 3 on both sides, and we're left with an x here because the two 3's reduce down to 1 on top of 1. It's just 1x, x, and 12 divided by 3 is 4. In our final example, we'll try to make it a little bit more complicated here. And we'll have a number of operations. So for example, we have x minus 5 all over 3 plus 2 is equal to 7. So how we handle this, we got to remember that we want to get rid of all of these items that are on with the x. We want to isolate x all by itself. And how we do that is to make sure that we follow the order of elimination, which is SAM-DEB. By following SAM-DEB, we can see that we need to get rid of the subtraction and the addition first. This holds a little problem with us for this example because we can see a subtraction here and an addition. Normally when we do that, we want to read from left to right. However, in this case, we've got a bit of a problem because the subtraction is in the numerator. So what we say here is the whole numerator is basically covered with brackets. They're invisible brackets, but they are definitely included here. So since they're in the brackets, the subtraction then becomes part of this final b, the final operation to get rid of here. So going with this, we take a look at getting rid of the addition. So we have the x minus 5 all over 3. We have plus 2 minus 2, and that equals 7 minus 2. We have to do the same operation to both sides. So we simplify this to be x minus 5 divided by 3 is equaling now to 5. Next thing here, we have our divide by 3, because remember that in the numerator we have these invisible brackets there, so we can't touch those yet. So when we multiply both sides of the equation by 3, we, in a sense, eliminate or reduce the 3's, because 3 over 3 is just simply 1 over 1 or 1. And then we have the x minus 5, which is equal to 5 times 3, 15. And our single step left is to add 5 to both sides of the equal sign. And so our final answer here, x is equal to 20.